Okay, test 1 review. There are 32 questions from 10 different sections from chapter 1 and chapter 2. So the first question is find the slope and then y-intercept of the line with the following equation. So if you have a question like this, you have to compare the equation with slope intercept form, which is y equal mx plus b form. So in this case, let's see y equal mx plus b. Write down this, just copy the equation from the question. Y equals 7 over 8 x minus 3. So the slope is the number in front of x, which is 7 over 8. The slope is 7 over 8. Always read the instruction, type an integer or simplified fraction. This is simplified fraction. So that is the slope. And then y-intercept is, if you focus here, this value of b, which is -3, gives you the y-intercept, but they want us to put the answer in order pair, so y-intercept supposed to be always 0 and then value of y, which is -3. Find the slope and y-intercept. Very similar question, but you need to first change the form of the equation you have given. So here we have 5x minus 4y equal 11. We need to write down this as a y equal mx plus b. That means we have to bring this 5x to the other side. We can do it by subtracting 5x. So -4y equal -5x plus 11. We don't want this -4 in front of y, so we just have to divide both sides. Both side means everything on the other side by -4, and that gives us y equal negative times negative divided by negative is positive. 5 over 4x minus 11 over 4. So now if we compare this with mx plus b, the m would be 5 over 4 and then b would be -11 over 4. So the slope of the line would be 5 over 4, simplified form. Luckily it's already simplified. And then y-intercept in order pair is 0 comma -11 over 4. Let me double check the answer. Yeah, so that's the answer. Write an equation for a line passing through up the point 3 comma 7, and that is parallel to this. So for equation of line, passing through a one point, there is a formula you can apply. Like if you have a line and if you know one point on that line, let's say that point is x1 comma y1, and if you know the slope of the line, this is the slope, then there is a formula that's called point slope formula. This is the formula you can use, but to use this formula you need one more information. The point you already know, 3 comma 7, so you know x1 is 3 and y1 is 7. But for the slope you need to use second information, which is this line is parallel to the line, this line y equal 3 over 5x plus 4. So the meaning is two parallel lines, they have the same slope, so we can use this slope 3 over 5 for the line which we don't know the equation yet. So this would be y minus y1, which is 7. Slope is same as the line we have given, and then this is the equation. So we need to write it down in slope intercept form. So meaning we need to bring this -7 to other side and do the simplification. So y, I'm going to add 7 both sides, and I'm going to distribute this 3 over 5 here. So that would be 3 over 5x minus 3 times 3 is 9 over 5. And if I bring this -7 to the other side, it would be +7. I just have to simplify this -5 over -9 over 5 plus 7. So let's simplify that. How do you simplify? Just add -9 over 5 plus 7 over, we don't have 5 here, so I'm going to multiply the top part and bottom part by 5 to make the same denominator. So it would be now -9 plus 35 over 5, which is 35 minus 9 is 26 over 5. So the equation would be 3 over 5x plus 26 over 5. So 3 over 5x. So y equal 3 over 5x plus 26 over 5. Let me double check. 26 over 5. That's the equation. A second slope intercept equation for a line passing through the point 37 that is perpendicular to the given line. Remember, if two lines are parallel, then their slope are equal. But if two lines are perpendicular, then the slope of, let's say you have one line, these two lines. Let's say slope of the first line is m1 and then slope of the second line is m2. Then the relation between these two slope, if they are perpendicular, is this one. Product of their slope is -1. In this case, the line we're trying to find, the slope of that line is perpendicular to, because that line would be perpendicular to this line. So let's say the slope of that line is, we don't know, which is m1, and m2 is the slope of the given line, which is 3 over 5. Then when you multiply them, the slope, the product is supposed to be -1. If you try to solve for m1, then just multiply both sides by 5 over 3, which is cancellation. So the slope of the perpendicular line would be -5 over 3. So it's a very similar to this slope, but just a reciprocal and minus. So this would be the slope of the second line. And now by using the same equation like this, and then opposite the slope -5 over 3, by doing exactly the same thing, you can solve this part. Okay, so one more time, the equation would be y minus y1 m1 this time, because m1 is the slope, x minus x1. So y minus 7, because it's also passing through the same point 3 comma 7 according to the problem, 3 comma 7, and the slope is -5 over 3, x minus 3, and then just do the simplification the way we did before, add 7 both sides. So that would be y equal, on the left side there is y, and on the right side distribute this -5 over 3 plus 5 over 3 times 3 is 5, negative times negative is plus 7. So the answer would be -5 over 3x plus 12. So that is y equal -5 over 3x plus 12. That's the equation. Write an equation for a line passing through 3 comma 6 that is parallel to. This problem is very similar to the question number 3, so I'm going to skip this. Determine whether the scatter plot on the right might be modeled by a linear function. So is this a linear function? No, because as you can see here, if you try to plot a graph here, it does not look like a linear, it looks like some kind of curve. So it's not, no. It's supposed to be a straight line. Like here, this is, if you try to join them, then model is like a linear function because it's a straight line. Money is borrowed at 11% simple interest. After 1 year, $1,319.79 pays off the loan. How much was the originally borrowed? So to answer this question, you have to know the simple interest formula, which is interest equal principal times rate times time. So in this problem, we know what is the what is this called, rate, and what is the final amount they paid back. So this is not the interest, this is interest plus principal. So sorry, interest plus principal is 1,319.79 after 1 year, so the time is 1. So how do you write it? Interest plus principal is it's a $1,319.79. We know interest is P times R times T. We don't know the principal, but we can use this as a linear equation. And now we can plug the rate. Always we have to use the rate in decimal. So 11% means 0.11, and time is 1 year. So time is always in year. So I'm going to put this information here. I'm going to factor out P. So the rate is 0.11, time is 1. So 0.11 times 1 is itself plus 1. If you factor out P, there will be 1 left over from here, 1,319.79. So to find the P, just divide both sides by 1.11. So principal, which is original amount borrowed, is this divided by 1.11. So you need to use a calculator to do this type of calculation. Here type $1,319.79, and that is the number we have given here, $1,319.79, and divide by 1.11. So the original amount was 1189. Okay, the chart to the right shows a country's annual egg production. So in 1994, the number of eggs in billions, 52.7 billions, 1995, 1996, and keep going. So you can take this time and then number of egg as an order pair. So this is the x coordinate and this is the y coordinate. So x represents the year, x0 means starting time, x1 means next year, which is 95, and so on, so on. Then we need to predict the production of egg in 2000. Predict egg production in 2000. Okay, here is the thing. We don't need to predict because it's already given, but they still want us to model this as a linear and then predict it. So let's try to use their data here, 1994. So 1994, remember this is starting here, which is 1994, which is 0. 1 means 5, 2 means 6, 3 means 7, 4 means 8, 5 means 9, 6 means 10, and keep going like that. So in 1994, it's a 52.7 billion. So 1994 means 0. This is the point we need to use, 0, 52.7. And then 1998 means after 4 years, 1, 2, 3, 4 years, which is 4. It's a 61.3. So to model this data using the linear function, you need to find out this equation, which is a straight line. And how do you do that? Like we did previously, by using the point slope form. So first of all, let's find out the slope. We know the difference between the y coordinate over the difference between the x coordinate. This formula gives us the slope for this line. In this case, let's assume that this is the first point and then this is the second point. So y2 is 61.3, y1 is 52.7, divide by x2 is 4 and x1 is 0. So use a calculator, subtract 61.3 minus 52.7, okay, 52.7, and divide that by 4. That gives you the slope, which is 2.15. We have the slope, and take one of the points. So y minus y1 m times x minus x1. By using this formula, you can find out the value of the equation of the line. So y minus y1, which is, in my case, it's a 52.7. The slope is 2.15. X minus x1 is 0. So I need more space here, so I will go here. So y minus 52.7 equal 2.15x. So y equal 2.15x plus 52.7. So this is the linear model. Remember, this one is 2.15, okay, 2.15, this one. So using this linear model, we would like to predict what would be the egg production in 2000. So from 1994 to 2000, the value of x is 6. So replace this x by 6, multiply by 2.15 and add 52.7. So if I do that, that is 2.15 times 6 plus 52.7. So that is the number of eggs, 65.6. The linear model for the data is, that's the equation they are asking you, y equal 2.15 x plus 52.7. This is the linear model. Type your answer in the slope intercept form. So, and then the billions in 2000 would be this calculation we just got, which is 65.6 billion. 65.6 billion. So as you can see here, we already know the data gives us 70.8, which is actual value, but based on our model, the value is less than actual value. It's okay. Okay, so this problem is very similar to a previous problem. You have the x coordinate, you have the y coordinate. You try to model this data using the linear equation. Do exactly the same thing we did like before, and then answer the question. Okay, the stopping distance at some fixed speed of regular tires on glare ice is a function of the air temperature F. So distance is the function of the air temperature F. This function is given by this. So distance of temperature is equal to 2 times the temperature plus 115. So what is the value of the distance when the temperature is 0? So 2 times 0 is 115. You just use this formula and find the formula when f is replaced by this number. So if f is replaced by negative 40, then you can see you go here, it's 2 times d negative 40 is, you go to the formula, you replace f by negative 40 and then do the calculation, which is negative 80 plus 115, which is 35. So the answer is 35 here. Okay, similarly you can find for the 10, I can do the same thing. 2 times 10 is 20, 20 plus 115 is 135. 135. 18 is 2 times 18 is 36 plus 115 is 151. I'm just using a calculator to do this calculation. So now plot these points to get the graph of this linear equation. Which of the following is the domain of the function? So the domain of the function, as you can see here, you have to choose from the graph. Domain of the function, as you can see, it's negative 57.5, negative okay, this question is a little bit tricky, so you have to, for find the domain, you have to be careful what type of function, the actual real function you are dealing with. This is the distance function, so distance has to be always, the distance has to be always greater or equal to 0. You know, it cannot be negative. So the value of the distance, which is 2 times temperature plus 115, has to be greater or equal to 0. So 2 times f is supposed to be greater or equal to negative 115, and if you divide by 2, it gives you f supposed to be greater or equal to negative 7.5. That's the value, the lowest one. And if you read the question carefully, it says the distance of regular tires on a glare ice would melt if the temperature is greater than 32°F. So the temperature has to be less or equal to 32, and then this is the lower bound, which is f has to be greater or equal to 57.5. In that way, we can say that the domain, the temperature is supposed to be in between these two numbers. So negative 57.5 and then 32. Determine the interval on which the function is increasing. Just go here and then you can check the function is going up, starting from negative 5 up to positive 1. Negative 5 up to positive 1. So negative 5 up to positive 1, the function is increasing. The function is decreasing from 2 to 4. As you can see here, the graph is going down, 2 to 4. And then function is constant from 1 to 2. From 1 to 2, the function is constant. Okay, so the same thing you have to find out increasing, decreasing, constant. So I'm going to skip this one. Let's go to the next problem where the function has a relative maximum value. As you can see here, the graph has relative maximum value here. So the relative maximum value is the y coordinate. Let me just make it bigger. The y coordinate is 8.25 at negative 5.5. So the relative maximum value is 8.25. Type integer or decimal at negative 5.5. From the graph, we can answer that question. So the minimum, as you can see here, you don't see anywhere the function has a relative minimum. So the function has no relative minimum. The function is increasing. As you can see, the graph is increasing to the left of this maximum value, which is negative 5.5. So to the left side, it's going up to this point and then going down. So the increasing from negative, the function is increasing on the interval from negative infinity up to negative 5.5. That's where the function is increasing, and the function is decreasing from that negative 5.5 up to positive infinity because it's going down. If you look at the graph, you can see that. Okay, watch the video, then solve the problem given below. So I'm not going to watch it. Determine the interval on which the function is increasing. So increasing, decreasing, again constant, again increasing and constant. I'm going to skip it because I already discussed about this problem. For the piecewise function, find the value. So to find the value of this piecewise function, you have to be careful and then pay attention to the point when x is negative 9. So if x is negative 9, you are going to use the first formula. So negative 9 plus 7 is negative 2 to calculate the value. So you find where that x from. If x is 3, because there is an equality sign here, still you are going to use the first formula. 3 plus 7 is 10. That's the value. And then for anything greater than 3, which is in this case 9, use the second formula. So 8 minus 9 is negative 1. 8 minus 9 is negative 1. One more time, very similar question. I'm going to skip it. Here you need to find a different quotient. Different quotient means find the difference between the function and then divide it by h and simplify. So first of all, copy your function, which is in this case f of x. F of x is negative 5x plus 4, and then find the difference between fx and then fx plus h. So you need to find out the fx plus h first. Using this formula, it would be negative 5 replace this x by x plus h. That's the meaning of finding the value at x plus h, and distribute this negative 5. It will be negative 5x negative 5h plus 4, and now we need to find the difference between them. So what is the value of f x plus h minus f of x? So you copy this thing, negative 5x negative 5h plus 4 minus this one. So when you take the minus, make sure you apply the sign rule. So negative times negative would be positive 5x, and negative times positive would be negative 4. So I just skip one step here, just follow the sign rule and then do the simplification. This positive 5x and this negative 4 and positive 4, they will be cancelled out. So this difference is only negative 5x. Now we would like to divide this difference by h. So we are dividing this negative 5h by h, and it will be negative 5 only. So the difference quotient is negative 5. The difference quotient is nothing but just the slope of this line, which is negative 5. One more time, find the difference quotient. So I'm going to skip it. Go to the next problem. Again, difference quotient. You just have to do a little bit simplification here. Keep in mind, the only thing is, I'm going to show you one step here. The function is x squared minus 4, and finding the value of the function at x plus h means just go here and replace this x by x plus h and do the squaring. So if you multiply x plus h with the x plus h, you are going to get x squared plus 2 times xh plus h squared minus 4. If you don't see it, then just multiply x plus h and x plus h. Just FOIL it. It's going to give you that value I'm talking about. So now you're going to use this value and then subtract this value from here. So eventually the value would be 2xh plus h squared if you find the difference. So the difference would be fx plus h minus f of x would be this x squared will be cancelled out, this 4 will be cancelled out after simplification. So remember, I'm skipping that simplification part because we did the same thing in previous problem. So I hope you can just follow that. The difference would be this, and now you are dividing this by h, meaning factor out the h on the top. So that will be this, and this is after simplification, which is 2x plus h. So 2x plus h is the final answer. Okay. Okay, I'm going to skip question number 20. Very similar question. Here 21, it's this is composite function. So find the value of composition. How do you find it? So f of x is given, which is negative 5x minus 1. G of x is also given, which is x squared plus 5. You want to find out f composite g. Let's find out first for the x, and then we replace this x by negative 4 to answer this question. Finding this means finding the value of f at g of x, meaning we go to the formula of f of x. This formula I'm talking about, negative 5, negative 1. We copy everything except x, and instead of x, we replace that by the value of g of x, which is x squared plus 5. When you try to replace the value, always use the parenthesis to make sure that you distribute the number and then sign in front of it. So if you just distribute negative 5, it will be negative 5x squared plus negative 5 times positive 5 is negative 25. So it would be negative 5x squared negative 26. Okay. So now this is the general function. We would like to find out the value of this function when x is negative 4. So you go here, replace this x by negative 4, do the calculation. So negative 5 times negative 4 squared is 16 minus 26. 16 times 5 is 80, which is negative 80 minus 26. Okay, so negative 80 minus 26, so that is I'm going to do it here, negative 80 minus 26, which is 106. So negative 106 is the value. One more time the composition, I'm going to skip that. One more time the composition, but this time we also have to find the domain, so I'm going to do this. Find the composition first using the very same idea. F composite g x is find the value of f at g of x. I go to the formula of fx, I replace x by the value of g of x, so that will be g of x plus 4. G of x is 2x square minus 7x minus 4 plus 4, and that is, this is gone, 2x square minus 7x. So that's the composition, 2x square minus 7x. Okay, so that's the composition. And the domain is whenever we try to find the domain, you have to follow 3-step process. Step 1, find the domain of the inner function. In this case the inner function is g of x, so the domain of g of x is all real number. Second, find the domain of the formula we got for this calculation, which is actually the composition, but this is not, we don't say for the sake of finding this, we say this is the new function. Find the domain of the new function, which is, again, in this case it's an all real number. Now the final step is the domain of the composition would be intersection between 1 and 2. So 1 intersection 2, intersection between the all real number to the all real number is actually all real number, so we can just say, hey, it's a all real number, so that is negative infinity. Okay, this is negative infinity to positive infinity, which is all real number. Okay, by doing the same thing, now this is just opposite order, exactly the same thing, so I'm going to skip it. You can finish that without any problem. This question, again the same thing. I'm going to do the first part because the function looks a little bit different. So find the composition of f, f composite g x, finding the value of f at g of x. So go to the formula for f, and wherever you see x in that formula, replace that by the value of the function g of x. So 6 over 1 minus 5 times g of x is a 1 over x. Okay, so that would be, now you do the simplification, 6 over this. After simplification, you're supposed to have, there is a 1, but you're supposed to have x on the bottom part to simplify. So we're going to multiply the top part and bottom part by x, which is actually 1. So by doing that, it would be x minus 5 over x. And if you flip it, because division means flipping, 6x over x minus 5. So that's the composition. What is the composition? It's a 6x divided by x minus 5. Okay, and what's the domain? One more time, for finding the domain, we need to use a 3-step process. The step 1 is find the domain of inner function g of x. In this case, the domain of g of x is all real number except 0, because 0 is going to make this function undefined. So this is how you write all real number except 0. Here, the domain of the new function, this is the new function after this calculation, it's all real number except 5. So it's a negative infinity to positive 5 and positive 5 to infinity. Number 3, the domain of actual, the composition is intersection between them. So look at here, one has a domain all real number except 5, another has a domain all real number except 5, except 0 and except 5. So the common between them is all real number except 0 and 5. That's the common part. So it's a all real number except 0 and 5, and this is how you write it: negative infinity to 0, 0 to 5, and 5 to infinity. So that is, you need negative infinity to 0 and union 0 to 5 union 5 to infinity, because the domain, oh, what happened, what did I do wrong? Let me just double check. Okay, let me just double check. Okay, so here you go. The domain of the g of x is all real number except 0, and domain of this final calculation is all real number except 5. This is how you write. So the intersection between 1 and 2 is supposed to be all real number except 0. So 0 cannot be included, 5 cannot be included. So how do you write it? Negative infinity. Simplify your, oh, sorry, it's not the domain they're asking you. They're asking you the composition from other side. Sorry about that. This is the answer we're going to give next step. Okay, so keep this. I did not read the question properly. I was just trying to complete the work. So the domain, they are not asking you the domain. This answer is going to be used later. Okay, first find the composition in a different order. So they are asking you to find g composite of f x, which is finding the value of g at f of x. So go to the g of x, replace x by f of x. So in this case, f of x is 6 over 1 minus 5x. Flip it. That's the way we divide. So it would be 1 minus 5x over 6. So the answer for this one is 1 minus 5x and over 6. Okay, 1 minus 5x over 6. Let me just double check. 1 minus 5x over 6. Good. Now for the domain of the first composition, the answer we just got before, this is the answer we're going to write. And where comma negative infinity to 0 sorry, and 0 to 5 and 5 to infinity. And the domain for the next part is do the same thing, like 3-step process. Domain of the f of x, which is all real number except the x which makes this thing 0, which is let me find out. 1 minus 5x equal to 0, 5x equal to 1, so x equal 1 over 4. Except this number, the domain is all real number. So domain of f of x is all real number except 1 over 5. So I'm going to write down that. How do you write it? You start from negative infinity, go up to 1 over 5, union 1 over 5 up to infinity. And then domain of this final formula is nothing. There is no restriction, so it's all real number. So the intersection between 1 and 2 is 1, because 2 is all real number. So intersection between 1 and 2, which is actually the domain of this composition, is this one. So you write negative infinity up to 1 over 5, and then union 1 over 5 up to positive infinity. That's the domain of this composition. Excellent. Okay, this is again composition. I'm going to skip this question. Okay, determine whether the graph is symmetric with respect to x-axis, y-axis, and then origin. The rule is for the y-axis, you just replace x by negative x, and then if it still gives you the same equation, in this case if I replace x by negative x and then try to simplify it, so after factoring negative, it would be equal to 0. Is this same as the first equation? The answer is no. so it's not symmetric with respect to y-axis. For the x-axis, replace y by negative y in the same equation, and then if you do that, you are going to get the same thing like here. So this is not symmetric with respect to x-axis as well. What about the origin? Let's do both of them, replace by negative, and then in that case it would be negative 3x positive 3y equals 0, and if you factor out negative, this is equal 0. You can multiply both sides by negative and it's going to give you 3x minus 3y equals 0. So after simplification, we end up with the same equation. So that means this is symmetric with respect to origin only. No symmetric with respect to y-axis, no symmetric with respect to x-axis, and symmetric with respect to origin. So what is that? A. Okay, symmetricity, do the same thing, replace x by negative x, y by negative y, and then whatever I did for the previous problem, and find out the symmetricity. Okay, this graph is symmetric with respect to y-axis. That's a definition of that's clear here. So it's symmetric with respect to y-axis. That's the definition of actually the even function, but they're not asking us the even function here. Determine visually whether the graph is symmetric. This is symmetric with respect to x-axis. Is the graph symmetric with respect to x-axis? Yes. Look, the x-axis is dividing the graph into two equal pieces. Is this symmetric with respect to y-axis? No. And then origin? Of course not. So let's go to the next question. Symmetric with respect to, again, x-axis? No. Y-axis? Again, no, because they are moving the graph to the right side. It's symmetric actually across this x equal to 1 line. Origin? No, for sure. Okay, write an equation for the function that has the graph with the shape of y equal x square but upside down and shifted 6 units left. Okay, so you start with the y equal x square, which means this, and upside down means this y becomes negative y. So that can be done by putting negative in front of the formula. Shifted left 6 units, so this graph is shifting left, so it's a horizontal shift. Whenever it goes to the left side, you are actually adding according to the rule. So if it goes to the right, you are subtracting from x, but if you are going to the left, you are adding to the x. So this would be the final formula. So the function would be negative x plus 6 to the power 2, upside down and then going left. What about the next one? Upside down, shifted left. One more time. That's the very, very similar type of thing, but this time 7. X plus 7. What happened? What did I do? But upside down and shifted left 7 unit and up 3 units. So I forgot about the up 3 units. So it's here is the function. You want to upside down, that means you want to put negative in front of x squared, in front of that, and then shifted left, which means you want to add 7 to the x, and then up, which means you want to add 3 to this calculation. So I missed the 3 here. Okay, so that's the test 1 review.